This is section 3.4, which is on the chain rule. Okay, you can find the chain rule on page 198. This is how you differentiate a composition of functions, something that looks like f of g of x. Okay, so we have a composition, capital F is f circle g. Okay. Then to differentiate, capital F prime of x is little f prime of g of x times g prime of x. So basically, you take the derivative of the outside function with respect to the inside function, and then multiply it by the derivative of the inside function. Okay, so capital F prime of x is little f prime of g of x times g prime of x. You can also use the Leibniz notation. If y is f of u and u is g of x, then you can write dy dx as dy du, du dx. And this kind of looks natural. It almost looks like you can cancel out the du's. So you have dy dx, dy du, du dx. Okay, so there's going to be inside function and an outside function. You differentiate the outside function with respect to the inside function, and then multiply by the derivative of the inside function. Now, the inside function might be a composition in itself, so you have to do it again, hence the term chain rule. Sometimes you chain one derivative times another, depending on how many levels. In one of the homework problems, there are 5 levels, so you have to differentiate. You just keep going inside until you unravel them all, so to speak. Okay, all right, so that is the chain rule. Let's take a look at the homework. So we had to go up to problem 65, it looks like, page 204. That's more. Okay, 55 at the bottom, there's the graphing calculator icon. Skip any graphing calculator icon because I'm not requiring you to have a graphing calculator. And 65 should be there. Okay. All right, so how do I do this chain rule? Number 7. Okay, so it's not just x to the 4th, it's a function to the 4th power. 5x to the 6th plus 2x cubed to the 4th. So the chain rule works like this. The outside function is raising to the 4th power. So I go 4, 5x to the 6th plus 2x cubed to the 3rd power. That's the same as usual. So that's the derivative of the outside function with respect to the inside, as we say. And then the chain rule says times the derivative of the inside function. So now I differentiate the inside, 30x to the 5th plus 6x squared. So that's the derivative. Okay, so one more time. Outside function is raising to the 4th power. So 4, blah, blah, blah to the 3rd, and then times the derivative of the inside. So 11 f of theta is cosine theta squared. So the outside function is the cosine function. Derivative of cosine is negative sine, so negative sine theta squared. And then the chain rule says times the derivative of theta squared, which is 2 theta. So final answer is negative 2 theta sine of theta squared. 13, x squared e to the negative x, product rule and chain rule. So there's a product. So dy dx first times the derivative of the second. So x squared times the derivative of e to the negative 3x. The derivative of e to the negative 3x is e to the negative 3x times the derivative of negative 3x. So outside function is exponential. Leave that alone. And then times the derivative of the inside function, it's the exponent. Derivative of negative 3x is negative 3. Plus second function, e to negative 3x, times the derivative of first, derivative of x squared is 2x. And then just a little bit of touch up. Negative 3x squared e to negative 3x plus 2x e to negative 3x. Okay, so d dx of e to the x squared, another way of saying give the derivative of e to the x squared for exponential functions, it's e to the x squared times the derivative of the x squared, the exponent, which is 2x, so 2x e to the x squared. Okay, so that now leads us to differentiating to any base. We know the derivative of e to the x is just e to the x. What if I have the derivative of 2 to the x? Okay, so what's the derivative of 2 to the x? Well, the trick in proving it is to write 2 as e to the ln 2. Okay, so d dx of e to the ln 2. E to the ln 2 is still 2, right? So it's 2 to the x. And then I have a property of exponents that says if I have a power and then another power, I get to multiply the powers. So I'm asking the derivative of e to the x ln 2 Now ln2 is like 0.693. Okay, so it's like asking what's the derivative of 0.693x? Well, it's 0.693. So the derivative of this is the same thing times the derivative of the exponent, derivative of x ln2 as ln2. Then I can rewrite this back as 2 to the x. So 2 to the x ln2. So essentially, bottom line, what happened from here to here, you copy the 2 to the x, but you have to multiply it by ln2. So in general, if you have any base positive, the derivative of a to the x is a to the x ln a. Okay, so it's a little bit awkward. So the derivative of e to the x is e to the x. If you have any other base, like 2, the derivative of 2 to the x is 2 to the x ln2. The derivative of 10 to the x, 10 to the x ln 10. The derivative of pi to the x ln pi. So it's a little bit trickier. Okay, put this on your cheat sheet also. Okay, 15, f of t is e to the at sine of bt. So product rule, in addition to the chain rule. So the derivative is first, e to the at, times the derivative of the second. Derivative of sine of bt is cosine bt. And then by the chain rule times the derivative of bt, which is b, the only variable is t, a and b are constants. Plus second function, sine of bt, times the derivative of the first. Derivative of e to the at is e to the at times the derivative of at with respect to t, and that's times an extra a. Okay, here's 25, a little bit clumsy. G of u is blah, blah, blah to the 8th power. Okay, so the outside function is raising to the 8th. So I start off with 8, blah, blah, blah to the 7th. And then by the chain rule times the derivative of the inside, which is going to involve a quotient. Okay, so 8 u cubed minus 1 over u cubed plus 1 to the 7th. And now differentiate the inside. Again, differentiate means take the derivative. So bottom times the derivative of the top, 3u squared, minus the top, u cubed minus 1, times the derivative of the bottom, 3u squared, all over u cubed plus 1 squared. Okay, this is 8 u cubed minus 1 to the 7th power. Ultimately, I have u cubed plus 1 to the 9th. That's u cubed plus 1 to the 7th. There's another u cubed plus 1 squared, so I have u cubed plus 1 to the 9th. And then I clean up the top there. So what do I have? I'll factor out the 3u squared. So 3u squared comes out. I have u cubed plus 1 minus u cubed minus a minus 1, which is plus 1. Looks like u cubed cancels out. So I have 2, 1 plus 1 is 2, times 3u squared, and then times 8. So 48 u squared, u cubed minus 1 to the 7th, all over u squared plus 1 to the 9th power. Okay, 27, r of t is 10 raised to the 2 radical t, that's 2 t to the 1/2. So now we know how to differentiate something besides base e. Base 10, I'm going to go 10 to the 2 radical t ln 10. Okay. Then by the chain rule times the derivative of 2 radical t, derivative of this is t to the negative 1/2. So best final answer, 10 raised to the 2 radical t ln 10 all over radical t. Okay, so just a sidebar here. To differentiate 2x squared plus 5x minus 7 cubed, the outside function is the cubing function. So I go 3 blah, blah, blah squared, and then times the derivative of the inside for x plus 5. Okay. And problem number 31. How do I differentiate e to the t sine 2t? So the derivative is the same thing, e to the t sine 2t, and then by the chain rule times the derivative of the exponent. So now I differentiate t sine 2t, that's a product. So first, t times the derivative of the second, derivative of sine 2t is cosine 2t times 2, plus second function, sine of 2t, times the derivative of the first, but the derivative of t is just 1. Clean up a little bit. So e to the t sine 2t times 2t cosine 2t plus sine of 2t. Now we have some real tricky ones here. F of t is tangent of secant of cosine t. So I have 3 levels here. Okay, so you chain one after the other. So chain rule, you just do one after the other. So outside function is tangent. So derivative of tangent is secant squared. I'm going to write down secant squared of everything behind my finger. Secant cosine t. And now it's times the derivative of the inside function. So I'm done with the tangent. Now I differentiate secant cosine t, which is a composition in itself. Okay, derivative secant of something is secant tangent. So secant cosine t, tangent cosine t. And then again by the chain rule, it's times the derivative of the inside function. Derivative of cosine t is negative sine t. And finally, I'm done. And there we go. Okay, 45 has 5 functions. So you have 5 levels. 5 functions are cosine, followed by square root, followed by sine, followed by tangent, followed by pi x. So you just do one after the other, just chain them. So outermost is cosine. So the derivative is negative sine. So I put negative sine of everything behind my finger, negative sine of radical sine of tan pi x. Okay, so cosine's done. The next outside function is a square root. So it's blah, blah, blah raised to the 1/2. So it's times 1/2 sine tan t, tan pi x to the negative 1/2. Okay. And now I'm done with the square root. Next function is sine. Derivative sine, cosine. So cosine tan pi x, done with that, times the derivative of tan pi x, secant squared pi x, times the derivative of pi x, which is pi. So there we go. So you just do one after the other, so to speak. Okay, 53, find the equation of the tangent to the curve, y equals sine of sine x at the point pi 0. So sine of sine x. So the outer function is sine. So y prime derivative of sine is cosine. So but cosine of whatever is behind my finger, cosine of the sine x, times the derivative of the inside function sine x, cosine x. Now I plug in pi. So put a pi here, cosine of the sine of pi times the cosine of pi. Sine of pi is 0. So I'm taking cosine of 0 times cosine of pi is -1. Cosine of 0 is 1. 1 times -1 is -1. So slope is -1, point pi 0. Point slope form, y minus y1 equals m times x minus x1. Y minus 0 equals -1 times x minus pi. Okay. That one. Okay, here is 3.4, number 17, jumping around here. 2x minus 3 to the 4th, x squared plus x plus 1 to the 5th. It's a product root with a chain root. Okay, so first times the derivative of the second, 5 x squared plus x plus 1 to the 4th times the derivative of the inside, 2x plus 1. Plus second function, copy down the x squared plus x plus 1 to the 5th power, times the derivative of the 4th, the derivative of the first, which is 4, 2x minus 3 cubed, times the derivative of the inside, which is 2, and etc. So you can clean up easy things like 5 times that, 4 times 2. That's the basic idea. Okay, 41. F of t is sine squared of e to the sine squared of t. Keep in mind, sine squared of x means sine of x squared. So the outermost function is the scoring function. You're scoring sine of blah, blah, blah. So go 2 sine of e to the sine squared t. Okay, so that's done. Times the derivative of sine of something, cosine of e to the sine squared t. Cosine's done. Times the derivative of the inside function. Derivative of e to the sine squared t is e to the sine squared t times the derivative of sine squared t, or sine t squared, which is 2 sine t times the derivative of sine t, which is cosine t. So that's 41. (47) y equals cosine of sine 3 theta. Outside function is cosine, so derivative is negative sine of 3 theta times derivative of sine 3 theta, which is cosine 3 theta, times derivative of 3 theta, which is 3. So I'll rewrite it as -3 sine of sine 3 theta times cosine 3 theta. Okay, so this is my first function. This is my second function. So now for y double prime, second derivative, I have the product rule. First times the derivative of the second. So copy all this stuff. Now times the derivative of cosine 3 theta minus sine 3 theta times the derivative of the inside. Derivative of 3 theta is 3. Plus second function, cosine 3 theta times the derivative of the first. So what's the derivative? -3 sine blah, blah, blah. -3 cosine blah, blah, blah. And then times the derivative of the inside, sine of 3 theta, which is cosine 3 theta, times derivative of 3 theta, which is 3. So there we go. Okay, and 61, how do I do 61? And so they give me all this information. They want f prime of 5. Okay, so f prime of 5. So capital F prime of x is f prime of g of x, g prime of x. So now I just plug in 5 here and 5 here. So g of 5 is given to be -2. So I have f prime of -2, g prime of 5. Okay, and I just look at my table. F prime of 2 is 4, g prime of 5 is 6. 4 times 6 is 24. Okay, way back to number 9, the derivative of radical 5x plus 1. That's 5x plus 1 to the 1/2. So the derivative will be 1/2, 5x plus 1 to the -1/2, times the derivative of the inside, which is 5. So that gives me 5 over 2 radical 5x plus 1. Okay. And then let's see, 65. Yeah, let me do 65. That one requires a picture. So we have to base everything off this picture. So I'm going to have to bounce back and forth between the picture and what we have. Let me actually try to leave the picture here, so I don't have to keep carrying the book. Go like that. Okay. So A, u of x is f of g of x. Okay. U prime of x is f prime of g of x, g prime of x. Okay, and then they want u prime of 1. I plug in 1. F prime of g of 1, g prime of 1. Okay, so I need g of 1. So g of 1 is right here, 3. So I want f prime of 3, g prime of 1. F prime means slope, g prime means slope. So at 3, x equals 3, what's the slope for the f graph? So 1, 2, 3, the slope here. Okay, so if I connect that point with that point, that looks like -1/4. G prime of 1, the slope for the g graph at 1, it's here, over 1 and down 3. So -1/4 times -3, 3/4. V prime of 1, V is g of f of x. V prime of x is g prime of f of x times f prime of x. Plug in 1. V prime of 1 is g prime of f of 1, f prime of 1. F of 1 is 2. See, f of 1 is 2. That's 2. And then I want g prime of 2, but g prime of 2 does not exist. There is no slope at 2. That's a corner point. So the final answer is does not exist. And then C, g of x. W prime is g prime of g of x times g prime of x. Plug in 1. G prime of g of 1 times g prime of 1. So I want g of 1. G of 1 is 1, 2, 3. 3. So I want g prime of 3 times g prime of 1. Slope at 3, slope at 1 for the g graph. So the slope at 3, 1, 2, 3 is right here. Rise over the run looks like it's 2/3 over 3 and up 2. G prime of 1 is -3. Okay, when I'm right here, for the g graph, it's over 1, down 3. So 2/3 times -3 is -2 for that one. Okay. 17. 2x minus 3 to the 4th, x squared plus x plus 1 to the 5th. So first times derivative of the second, 5 times x squared plus x plus 1 to the 4th power, times derivative of the inside, which is 2x plus 1, plus second function, x squared plus x plus 1 to the 5th, times derivative of the first, 4 times 2x minus 3 cubed times 2. Okay, and then I would just clean up easy stuff. Okay, one problem way in the past, 3.219. Take the derivative of s minus radical s over s squared. You could do this by the quotient rule, but it's a lot easier to divide first. S divided by s squared is 1 over s, minus s to the 1/2 divided by s squared is s to the -3/2. Second right is s to the -1 minus s to the -3/2. So y prime is -1 times s to the -2 plus 3 halves, -3 halves times -1, 3 halves s to the -5 halves. Rewrite it with no negative exponents. So -1 over s squared plus 3 over 2 s to the 5 halves. Okay, so that's section 3.4, which is on the chain rule.